Right now, as you're watching this, there's an invisible shield protecting all of us, a silent planetary force field that's constantly deflecting deadly radiation from space. But what would happen if it just disappeared?
And look, this isn't just some science fiction plot. Our shield is actually weakening. And trying to understand the consequences, well, it's one of the most critical thought experiments we can possibly run. So, let's dive right in.
Okay, so first things first, what exactly is this shield? It's not magic, it's pure physics, and it's generated by this absolutely colossal engine deep in the heart of our planet.
We call it the geodynamo. I want you to picture an ocean of molten iron, literally larger than the moon, just churning away deep beneath our feet. That constant motion, combined with the Earth's spin, generates these massive electrical currents, and those currents in turn create our magnetic field. This field then projects way out into space, forming what we call the magnetosphere, and that is our planet's first line of defense against a constant storm of solar wind.
Now, here's where it gets really interesting and maybe a little concerning. This shield, it isn't permanent. Ever since we started properly measuring it back in 1840, the field has weakened by about 5% every single century. And this decay, it's not happening evenly across the globe.
And that brings us to something called the South Atlantic anomaly. The best way to think about it is like a growing dent in our planet's armor. In this huge region, the field is so weak that the Van Allen radiation belts, these zones of intense radiation, they actually dip dangerously close to the surface. Any satellites that pass through it get zapped, causing all kinds of malfunctions. It's a very real-world preview of what a global field collapse could look like.
So the most common fear you hear is that without the magnetic field, the solar wind would just strip away our atmosphere and turn Earth into a barren wasteland, kind of like Mars. But the actual science on this is, well, it's surprisingly reassuring.
The key difference between us and Mars really boils down to one thing: gravity. See, Mars lost its atmosphere because it lost its magnetic field, and it has incredibly weak gravity. Earth, on the other hand, has this powerful gravitational pull. And it's that gravity, not magnetism, that's the ultimate anchor holding our thick, dense atmosphere to the planet. So no, we wouldn't lose our air. The real threats are actually way more immediate, and they would begin with a terrifying cascade of collapse.
So if the danger isn't losing our air over thousands of years, what is it? Well, it's a series of rapid, interconnected disasters that would play out in 3 very distinct and very destructive phases.
First, almost instantly, our technology would be completely wiped out. Then, over a matter of months, the very chemistry of our atmosphere would be violently rewritten. And finally, over the course of years, the fabric of the biological world itself would begin to unravel. Let's start with the tech. Without our magnetic shield to buffer us, even a run-of-the-mill solar storm would be catastrophic. A study from Lloyd's of London estimated the high-end cost of a single severe storm could hit over $9 trillion. In a world with no field, that wouldn't be a one-time event. That would be our new permanent reality.
So what does that actually look like? Well, massive currents induced in our power grids would literally melt and destroy the critical transformers that keep everything running. We're talking continent-wide blackouts that could last for years. GPS would become totally useless as the ionosphere just turns into a turbulent mess, scrambling all the signals. And this isn't just about your map app. This would cripple global finance, logistics, communications, everything that relies on GPS for precision timing. And up in space, every satellite in low Earth orbit would either be fried by radiation or dragged out of the sky.
Just as our technology dies, Phase 2 would begin. With no shield, our planet would be bombarded by solar protons. These particles would trigger chemical reactions up in the stratosphere that could destroy 40 to 50% of the entire ozone layer globally. This isn't some small hole over Antarctica we're talking about. This is a planetary-scale disaster, exposing all life on the surface to sterilizing levels of UV radiation.
And that leads us directly into the third phase, biological disruption. Long before humans would face the full consequences, the animal kingdom would be thrown into absolute chaos. You see, so many species have a kind of internal compass, a sense called magnetoreception, that they use to navigate the entire globe. Without the field, that sense is just gone, broken.
And we've already seen scary hints of this happening. Back in 2016, 29 sperm whales got stranded and died in the North Sea. The likely culprit? Researchers think a solar storm distorted the local magnetic field just enough to trick the whales, essentially making them navigate into shallow, deadly waters. In a world with a collapsed field, This kind of tragic disorientation would become the norm for countless species.
Now, this is where the science gets really wild. For birds, it's even more incredible. They don't just feel the magnetic field. Through a quantum process happening in their retinas, they can literally see it. It's their primary map for migrating across vast oceans or on cloudy days. You take that away, an entire species could fail to find their breeding grounds, triggering a domino effect of ecological collapse.
Look, I know this all might sound like a pretty futuristic what-if scenario, but what if I told you we have evidence that something very similar has already happened in Earth's deep past, a warning written in ancient rock and ice?
About 42,000 years ago, the magnetic field temporarily collapsed during an event we now call the Longchamp excursion. For a few centuries, its strength dropped to almost zero. And right around that same time, we see these massive global changes happening. Megafauna in Australia went extinct, Neanderthals vanished, and early humans started seeking shelter in caves, which is right when we see the first great flourishing of incredible cave art.
So the big question is, was there a direct link? Well, the science is still being hotly debated. One theory suggests the field collapse triggered a global environmental crisis, but critics argue that, hey, the timing might just be a coincidence, and that massive glacial cycles were the real culprit. The most likely answer is probably somewhere in the middle, that the magnetic collapse acted as a force multiplier, dramatically making the effects of an already changing climate so much worse.
Okay, for our final point, let's zoom all the way in. We've talked about the planetary scale, the technological scale, but what would living in a zero-field world actually do to our bodies, right down to the microscopic level?
While research into these hypomagnetic or zero-field environments reveals some profound effects, plants showed delayed growth, microbes just stopped reproducing, and for humans, studies analogous to what astronauts experience in space suggested a world without a magnetic field could lead to increased bone loss, a suppressed immune system, and even cognitive decline. The takeaway is incredible. Life didn't just evolve to be protected by the field, it evolved to live within it. It's part of our fundamental biology.
So here's the crucial point to leave you with. We wouldn't die because we lost our air. We would face a world of cascading failures, technological, chemical, and biological. Our entire global civilization, everything we've built, was constructed during a period of relative magnetic calm. And that leaves us with a really critical question. How resilient could we possibly be when that calm finally turns into a storm?